Number 31. The expression, this one, could be written as A is congruent to B modulo M. So that is, M divides the difference of A and B. Could be written in this format. Which of the following is true? Is A, B, C, or D correct? What do you think? Please pause the video if you need to and solve. Let's proceed with the solution. If I have 9 is congruent to 5 mod 3, it could be written back as 3 divides 9 minus 5. But if you could see 9 minus 5 is 4, you could see that 3 divides 4 is false because 3 is not a factor of 4. How about letter B? 19 is congruent to 7 mod 5. From here, writing it into this format, this will become 5 is congruent to the difference of 19 minus 7. I mean, 5 divides 19 minus 7, or 5 divides the difference, which is 12, which is again false because 5 is not a factor of 12. For letter C, 37 is congruent to 18 mod 7. It will become 7 divides 37 minus 18, or 7 divides 19, which is false again, considering that 7 is not a factor of 19. And for letter D, 47 is congruent to 20 mod 9. This could be written as 9 divides the difference of 47 and 20, which is 47 minus 20 is 27. 9 divides 27. This is true since 9 is a factor of 27. So we'll go with letter D. All right, 32. What is the remainder when 2 raised to 130 is divided by 7? Is it 2, 3, 4, or 5? So we can do modular arithmetic here. What do you think is the correct answer? We will see. This is the expression that we're looking for. 2 raised to 130 is congruent to blank mod 7. We will look for the value of the number in the blank. And since we are talking about remainder, and our divisor here is 7, so our answer could either be 0, 1, 2, 3, 4, 5, or 6 only. If your answer is 7 or above, then there's something wrong because remainder should not exceed the divisor. So if you could see, you could start with 2 cubed. You might ask, how come, sir, you started with 2 cubed? If I start with 2, 2 squared is 4, 2 cubed is 8, and if I divide 8 by 7, the remainder is 1. That's the trick here. If you have a remainder, if you have 1, the better, because 1 raised to any exponent will give you an answer of 1. So that's why I have 2 cubed. It's congruent to its value itself, which is 8, mod 7. If you divide 8 by 7, the remainder is 1. That's why you will have 2 cubed is congruent to 1 mod 7. So the left side should be written in exponential form, but the right side, as much as possible, should be less than 7 or less than your divisor. And next, our goal is 130. So what should you raise to 130? To 3 rather. That's somehow the largest one that's near 130. It's smaller, but near 130. So the technique is you divide. You divide 130 by 3. It's 43 point something. And so you just adapt or use the whole number part, which is 43. So you raise both sides to 43. Take note, raising both sides to the same natural number preserves the congruence. And doing such, if you're raising a power to a power, you copy the common base, which is 2, and you multiply the exponents. 3 times 43, which is 129. It's congruent to 1 raised to 43, which is still 1. So we have 2 raised to 129 is congruent to 1 mod 7. However, you are looking for 2 raised to 130. What should we do multiply with 2 raised to 129 to reach 2 raised to 130? We should multiply 2. That's why we multiply both sides by 2. 2 raised to 129 times 2 becomes 2 raised to 130, which is congruent now to 1 times 2, which is 2 mod 7. So you see, we have reached our desired format, and it's 2 here. Hence, the remainder is 2 when 2 raised to 130 is divided by 7. Letter A. 33. If K is the matrix 1, 3, negative 4, 5, and J as the matrix 1, negative 7, 5, negative 3, then K plus J is what? Note that we can only add matrices that are of the same dimensions. So this is a 2 by 2. This is also a 2 by 2 matrix. And to add them, we have to add the first element here with the corresponding element here, the 3 to the negative 7, negative 4 to 5, and 5 to negative 3. That's why the sum of these two matrices is this expression. And simplifying each would give us K plus J, which is 2, negative 4, 1, 2. Letter A is the answer here. All right. So far, so good. 34. If K is 1, 3, negative 4, 5, and J is 1, negative 7, 5, negative 3, then what's the product of these two matrices KJ? Is it A, B, C, or D? One thing that we have to note is that in general, multiplication of square matrices is not commutative. Note that only square matrices of the same dimensions could be multiplied. 2 by 2 could be multiplied with 2 by 2, 3 by 3 with another 3 by 3, and so on. Square matrices, matrices that are not square matrices could not be multiplied. And so, since multiplication of matrices, as what I have mentioned earlier, is not commutative, and we have KJ, so K will be listed first, will be at the left, and J will be at the right. And to do this, we will multiply first the corresponding entries in the first row of the first matrix and first column of the second matrix. So we have here 1 times 1 here, plus 3, and we have to add it with 3 times 5. Next, we have the second row of the first and first row of the second. Their intersection will be found here. So negative 4 times 1 plus 5 times 5 here. Next, for this part here, we have to multiply the first row of the first matrix and the second column of the second matrix and their corresponding entries. So 1 times negative 7 here plus 3 times negative 3. I think this should be negative 3 here. All right. And next one, the second row and the second column. So we have negative 4 times negative 7 and plus 5 times negative 3. And if you simplify this one, this is 1 plus 15 or 16. Negative 7, this one is negative 9. 3, that's negative 7 minus 9, that's negative 16. And we have here 21 here, okay? If you simplify this, This will give you 28 minus 15 or 13. And it's not one of the choices, so we will go with letter E. I hope you got it correctly. So we were able to see some flaws in the solution, and it's good that we were able to correct them. 35. If k equals the set, this one, then what is the value of the determinant of k? 14, 17, 15, or 18? To get the determinant of a square of a 2 by 2 matrix or of this square matrix, the formula is quite simple. That is, in concept, or if we have K, this matrix K, with these entries in the 2 by 2 matrix, then to get the determinant, you just have to multiply this one first, A times D. Upper right times the number in the lower upper left times lower right, and subtract it with the entries in the lower left and D with the product of the lower left and the upper right. That's why you have AD minus BC. So since this is the given matrix, so for the determinant, so just multiply 1 times 5, that's this one, and subtract it with the product of negative 4 and 3 here. And that becomes 5. Negative 3 times negative 4 is plus 12. So it's 5 plus 12, which is 17, letter C. 36. Next one. Which of the following matrices below has an inverse? Which do you think of? A, B, C, or D is correct? We have to remember this. A matrix has an inverse if its determinant is not 0. So in this case, all the givens are 2 by 2 matrices. So let's solve for all of the determinants. So for letter A, that's 2 times 2 minus 1 times 4. That's 4 minus 4 or 0. For letter B, its determinant, it's negative 4 times negative 5. That's okay here. Minus 10 times 2. Okay. And if you could see, this is 20 minus 20 or still 0. For the third one, we have 5 times negative 2 minus 1 times negative 4. This becomes negative 10 plus 4 or negative 10 plus 4, or it should be negative 6. And lastly, for letter D, 3 times negative 3, it's negative 9 minus negative 1 times 9, which is negative 9 also. So it will become negative 9 plus 9 or 0. So you could see that A, B, and D have determinants that's equal to 0. So I'm sure that A, B, and D have no inverses. And since the determinant of C is negative 6, which is non-zero, so I am sure that C has an inverse. Letter C is the correct answer. 37. Find the inverse of the matrix K with elements 1, 3, negative 2, 5. This is quite a lengthy or tedious process, especially if you will be using methods like Gauss-Jordan or Gaussian method of elimination, operations rather, or row operations. There is another way of finding if it is an inverse or not, and that is by means of multiplication of matrices. Take note that if K inverse is the inverse of matrix K, by the way, K here is a square matrix, then the product of K and its inverse should be I, where I is the identity matrix. Identity matrix. The identity matrix for the case of an invertible 2 by 2 matrices is I, which has in the main diagonal, the elements are 0, and the rest of the elements, in this one, the elements or the numbers in the main diagonal should be 1, and the rest of the elements or the rest of the numbers should be 0. All right? So from here, if we try A, let's try option A. If we get the product of the matrix and its inverse, will it give us the identity matrix? Let's see. So by multiplication of matrices, first row times first column, 1 times 5 plus 3 times 2 11, so it's here. Next, second row of the first column of the second, and it will be reflected in this one. So -2 times 5 11s plus 5 times 2 11. So it's here. Next one, first row of the first, second row of the second column of the second. So 1 times -3 11s plus 3 times 1 11s here. And lastly, second row of the first, second column of the second. -2 times -3 11s plus 5 times 1 11s. If you could see, this is 5 11s plus 6 11s, which is 11 over 11 or 1. This 2 will become -10 11s plus 10 11s. So that becomes 0 over 11 or 0. -3 11s plus 3 over 11s will become 0 here. And lastly, this will become, the product of this is 6 11s plus 5 11s, which is 11 over 11 or 1. And if you could see, indeed, you have the identity matrix. And since the product of K and the option A, the matrix in option A results to the identity matrix, then we could say that indeed option A with elements with numbers 5 11s, -3 11s, 2 11s, 1 11s is indeed its inverse. Letter A. Number 38. Consider the mapping as shown. So take a look at this relation. Set B is called what? Is it called the domain, the codomain, the range, or the pre-image? If you answered letter C, range, then let's see if you got it. The domain here is in fact the first set here, A, which is 1, 2, 5, 7. In fact, each element of A is being mapped to B. So A here is the domain. The codomain here is in fact your B, which is everything inside set B, which are A, C, M, and N. Your range, if you could take a look, 1 is mapped to C, 2 is mapped to N, 2 and 7 are both mapped to N, and 5 is mapped to A. If you could see that M has no pre-image in the set A. Even though your codomain is A, C, M, and N, when we speak about the range, it is only the set of elements that have a pre-image. But since M has no pre-image, then only A, C, and N are in the range. And lastly, pre-image, it's your set A. It's your domain here in this case. We will go with letter B. Set B is the codomain. So I hope I was able to clear out some misconceptions. 39. If A is a set with 1, 2, 3, and B is a set with 5, 7, 9, 11, what is the cardinality of A cross B? Or I mean the order of the Cartesian product of A and B. Is it 12? 8? Is this has 3 elements? This has 4 elements. So is it 12, 18, 20, or 32? When we speak about Cartesian product of two sets A and B, denoted by A cross B, it is the set of all ordered pairs A and B, where A here is taken from the first set and B is taken from the second set. So it's simply noting all the possible ordered pairs. So since you have this, if we have A cross B, so 1 could be paired 1, 5. You could have 1 with 7. 1 could be paired with 9. 1 could be paired with 11. So we have here these ordered pairs so far, 1, 5, 1, 7, 1, 9, 1, 11. Next, we have exhausted everything for 1. We have 2. We will map 2 with every element in B to produce ordered pairs. So we have 2, 5, 2, 7, 2, 9, and 2, 11 here. And lastly, we have to map 3 to each, or we have to produce ordered pairs whose first element is 3. So we have 3, 5, 3, 7, 3, 9, 3, 11. And all in all, you could see that there are 12 of them. And to make the long story short, to get the order of the Cartesian product, all you have to do is multiply the cardinalities of the two sets involved. So we have 3 times 4 here. We have 12 such ordered pairs. Letter A. Number 40. Let f be the mapping from the set of real numbers to the set of real numbers, such that f of x equals 2x plus 1. Is f injective or one-to-one? Yes or no? Maybe or cannot be. For this question, it's either A or B. We will not answer C or D here. So yes or no, is it one-to-one? Note that if you see this notation, this one, it's the taken from your domain, and from R here is a set taken from your, this is your codomain. The X will be from real numbers, the Y will be also from real numbers. So to establish if it is injective, by the way, the other term for injective is one-to-one. So it's like asking, is f of x equals 2x plus 1 a one-to-one function? So the definition is, the abstract algebra definition is for all x sub 1 and x sub 2 element of real numbers in your domain. And suppose f of x sub 1 is equal to f of x sub 2, we need to show that x sub 1 is x sub 2 to claim that it is a one-to-one function or injective function. So by substitution, I will replace the x with x sub 1. So you have f of x sub 1 equals to x sub 1 plus 1. I also replaced the x with the x sub 2. So I have f of x sub 2 equals twice of x sub 2 plus 1. And we have to equate them here using this concept. So equating these two, we have 2x sub 1 plus 1 equals 2x sub 2 plus 1. Subtracting both sides by 1, you have 2x sub 1 equals 2x sub 2. Dividing both sides by 2, we have x sub 1 equals x sub 2. And we are able to show that indeed x sub 1 is equal to x sub 2 here. Since x sub 1 equals x sub 2, then f of x equals 2x plus 1 defined in this mapping is an injective or a one-to-one function. Letter A. I hope you got it correctly.